All right, let's take a look at our next lesson in our note packet, 7.5, Trigonometry, Finding Sides and Angles. Just a reminder that you need to watch the video today, take careful notes, and what you'll do at the end is take pictures of your notes and submit those pictures to Canvas, so make sure you take careful notes today. All right, our learning target today is that we're going to apply the trig ratios of sine, cosine, and tangent to find the lengths of missing sides and the measures of missing angles. We have already used the trig ratios to find the lengths of missing sides. We're going to see some review in today's lesson. But finding the measures of missing angles, that is new. So let's focus in on that. Before we begin, at the very top of your page, above example 1, you'll notice that this little sentences here. It says if you know the sine, cosine, and tangent ratio of an angle, you can use the inverse function. Inverse sine, inverse cosine, and inverse tangent to find the measure of the angle. The best way to explain this is that sine, cosine, and tangent are operations, just like addition, subtraction, multiplication, and division. What's the inverse operation of addition? Subtraction. What's the inverse operation of multiplication? Division. What is the inverse operation of sine? Inverse sine, or sine with this little -1. The inverse of cosine is inverse cosine, or cosine with a little -1, and the inverse of tangent is inverse tangent. Now, why would we need to use these? Well, let's see a few examples. Take a look at example 1. It asks us to find the value of x and round to the nearest tenth. What you'll notice is different in these examples is this. As we circle our acute angle that's labeled, you'll notice that it is labeled x degrees. In the past, we were given that angle measure and asked to find one of the sides. But here, the angle measure is missing. Now, let's go ahead and label our diagram like we've done before. 24 in this case is our hypotenuse. 15 is the opposite side. And this blank side over here is adjacent, though we don't end up needing that. Okay, we think so, ka, toa. So, ka, toa. Which one of our trig ratios uses, in this case, opposite and hypotenuse, since that's what's labeled? Well, that would be sine. Remember, so means sine of an angle equals opposite side over the hypotenuse. Now, in this case, the angle is x, so we're going to write sine of x equals the opposite side, 15, over the hypotenuse, which is 24. Now, I know this fraction can reduce, but we don't need to do that right now. Our main goal is to get x by itself. Now, how do we get rid of sine? You might think, oh, we need to divide by sine. But this is not sine times x. It is sine of x. Sine is its own operation. So if we want to undo sine, we use the inverse sine. So we need to take the inverse sine of both sides of the equation. Sine with a little -1, like this. But what we do to one side of the equation, we must also do to the other side. We're taking the inverse sine of both sides of the equation. Now on the left, inverse sine and sine cancel each other out, leaving us with x equals the inverse sine of 15 over 24. And all we need to do is to type that into our calculator. Now to be careful, inverse sine is not the same thing as sine. Pressing the sine button gives you regular sine, but if you want inverse sine, you might notice in mine it's in blue. In a slightly different color, up above sine, you see inverse sine. So press second sine, and then you can type in the fraction, which was 15 over 24. Close your parentheses and press enter. Now, one additional thing, it is important to make sure that you are in degree mode, which you can either see right up here, or you can press the mode button and make sure that you're in degrees instead of radians, okay? But if you are in degrees, you should have gotten an answer of approximately 38.7. So we can say that x is approximately equal to 38.7 degrees. Okay, let's try another example. Let's look at number 2. In number 2, we circle our acute angle, and we label 11 as our hypotenuse, and 8 as our adjacent side. I'm going to go ahead and leave that side unlabeled since we don't need it. Now remember, so, ka, toa. Which one of our trig ratios uses adjacent and hypotenuse? Well, that would be cosine. So we can say cosine of x equals the adjacent side 8 over the hypotenuse, which is 11. Just like before, x is trapped inside of cosine. So to get rid of cosine, we take the inverse cosine of both sides of the equation. When we do that, cosine and inverse cosine cancel, leaving us with x equals the inverse cosine of 8 over 11. So let's type that into our calculators. The inverse cosine of 8 divided by 11. And we should get approximately 43.3 degrees. So x is approximately 43.3 degrees. Okay, let's do one more together. Let's take a look at example 3. In example 3, let's label these sides. So here's our acute angle. 20 is opposite, and 37 is adjacent. Sine, cosine, or tangent, which one uses opposite and adjacent? Well, it's tangent. So we can say tangent of x equals the opposite side, 20, over the adjacent side, 37. Just like in the two previous examples, x is trapped inside of tangent. So how do we undo tangent? We take the inverse tangent. And what we do to one side, we must also do to the other side. Tangent and inverse tangent cancel out, leaving us with x equals the inverse tangent of 20 over 37. And let's type that into our calculator. We press second tangent and we type in 20 over 37, close parentheses, and we get approximately 28.4. So x is approximately 28.4 degrees. Awesome. What I'd like for you to do now is to pause the video and to attempt numbers 4, 5, and 6 on your own. So pause the video, try 4, 5, and 6, and then you can check your answers against mine in just a minute. All right, here are the answers to numbers 4, 5, and 6. If you need to pause the video and check, you can do that. All right. Now, as we look at the bottom of the page, you're going to see a bit of review here. So in each of these, you'll notice x is not our acute angle. So we're just going back and reviewing some ideas from the previous lessons that we've seen on trigonometry. So we can begin by circling all of our acute angles that we see here. We remember SO, CA, and TOA. Let's try number 7. In number 7, let's label the sides. This is our x is our adjacent side, and 11 is our opposite. Opposite and adjacent, that means we're using tangent. We can say tangent of 39 equals the opposite side 11 over the adjacent side x. Just like we talked about before, if 11 divided by x equals tangent of 39, then I can flip-flop these expressions. I can say that 11 divided by tangent of 39 equals x. And then we just need to type this into our calculators. You've seen this enough, but I'll go ahead and tell you, you can double check by using your own calculator. If you type that in, you should get approximately 13.6. So make sure you're checking that on your own. Let's try number 8 now. Same idea. Let's label the sides. 28 is our hypotenuse, and x is our adjacent side. Cosine uses adjacent over hypotenuse. So we'll say cosine of 46 degrees equals x over 28. This time we don't have to use anything too fancy. To get x by itself, we just have to multiply both sides by 28. And this is what we want to type into our calculator. 28 times cosine of 46. You've seen that done enough, but if you type it in right now, you should find that x is equal to approximately 19.5. So just make sure you're checking that on your calculator as we go. In number 9, same thing. Let's go ahead. Let's see, 8 is our opposite side and x is our adjacent side. Opposite over adjacent, that's tangent. So we can say tangent of 51 equals 8 over x. Because x is trapped in the denominator of a fraction, remember what this means. If 8 divided by x equals tangent of 51, then we can flip-flop these and say 8 divided by tangent of 51 equals x. And that's exactly what we're going to do. X equals 8 over tangent of 51. And this is what we're going to type into our calculators. If you do that and you round to the nearest tenth, you should find that x is equal to approximately 6.5. And let's take a look at number 10. And number 10, we'll go ahead and circle our acute angle, 24 degrees. X is our opposite leg, and 31 is the hypotenuse. Opposite over hypotenuse, that's sine. So we can say sine of 24 equals x over 31. Great. Now to get x by itself, all we need to do is to multiply both sides by 31. And this is what we'd want to type into our calculator, 31 times sine of 24. And if you do that, round to the nearest tenth, you should find that x is equal to approximately 12.6. Okay, let's go ahead and turn the page. Let's take a look at a few more examples where x represents a missing angle measure. We'll do numbers 11 and number 14. So we begin by circling our acute angle, which is x. We can do that on both of them. And by classifying the labeled sides. In number 11, 22 is the hypotenuse, and 14 is the adjacent side. Remember, so ka toa, adjacent over hypotenuse, that would mean cosine of x equals 14 over 22. Now to break x free of that cosine, we take the inverse cosine of both sides. This cancels out, and we've got x equals the inverse cosine of 14 over 22. And you've seen me type this into the calculator before. Remember to press second and then cosine, and type in 14 divided by 22. You should find that x is approximately equal to 50.5 degrees. And one more just to make sure that we've got that under our belts. As we look at number 14, we can see that 10 is the opposite leg and that 19 is the hypotenuse. Remember that opposite over hypotenuse is sine, so we can say sine of x equals the opposite leg, 10 over the hypotenuse, 19. We will use inverse sine to break x free of this sine right here. We apply that to both sides of the equation. That cancels out, so we have x equals the inverse sine of 10, oops, that's a 10 over 19. And then we would just type that into our calculators. Again, inverse sine, you can calculate that by pressing second and then the sine button. Then type 10 over 19, and you should get approximately 31.8 degrees. Awesome. Just a few more examples to look at. Let's look at number 15. In number 15, we have this situation where we have two right triangles that share a side. And what they want us to find specifically, let's label it together, they want us to find the distance from D to E. Okay, that's helpful, though the problem is, in this bottom triangle, we really don't know very much at all. We don't know any of the sides. We do know that there's a 19-degree angle here, but that's about it. So in order for us to get some more information about this bottom triangle, we're going to need to solve for this length right here. In fact, why don't we just go ahead and call this length, why don't we call it x, right? It's not our final answer, but we'll call it x. We need to find this length. So let's focus in on this top triangle. We'll circle the 61. Let's see, 24 would be the adjacent leg, and x would be the opposite leg. So we're going to be using tangent, opposite over adjacent. We can say tangent of 61 is going to equal the opposite leg, x, over the adjacent leg, 24. Okay, all we need to do here is to multiply both sides by 24, like this. This cancels out, and we're going to type this into our calculator. So 24 times tangent of 61 gives us this. Now, on our paper, we'll go ahead and write down 43.3. However, we want to make sure that we don't actually round our answer too early. So I'm going to keep this number in my calculator so that when I perform my next calculation, I don't work with 43.3, I work with this exact value. So to help me remember that this is an approximation, I'm going to write that this is approximately 43.3. It's not exact. Let's circle the 19-degree angle. And what we're trying to solve for over here, why don't I just go ahead and call this y, since I've already assigned x, okay? This is our opposite leg. 43.3 is our adjacent leg, which means we're going to be using tangent again. Let's go ahead and set this up. We want to say tangent of the 19 degrees, tangent of 19 degrees is equal to the opposite leg, that's y, over our adjacent leg, which was 43.3, again, approximately. In order to get y by itself, I know what needs to happen is I need to multiply both sides of this equation by that 43.3. I know that's not exact, right? But multiply by that approximately 43.3. So this cancels out. Okay? So in my calculator, I need to take not 43.3, but the exact value we got earlier, and then multiply it by tangent of 19. Let me show you what that looks like. The value we found earlier was right here. All you need to do is to press the multiplication symbol, and it takes the previous answer and multiplies it times whatever you want. In this particular case, we're multiplying times tangent of 19. And now, since this is our final answer, we can round it to the nearest tenth. Our answer is approximately 14.9. So we can write that y is approximately 14.9, or being more specific, y was representative of the distance from D to E, so it's probably best for us to write that DE is approximately 14.9. Okay, let's try one more like that. In this particular example, they want us to solve for the measure of angle W. Well, angle W is here. The problem is we don't know a whole lot about the rest of this triangle. In fact, we don't know the measures of any of the angles, other than, of course, the right angle. So let's turn our attention to this triangle over here. We know one of the angles and we know one of the sides. And our goal should be to find our bridge side, this one over here, that I'm going to call X. That way we can get some information about the triangle on the left. So here's our 25-degree angle. 15 is our opposite leg, and X is our hypotenuse. SOHCAHTOA, that's opposite over hypotenuse, we'll use sine. Sine of 25 equals opposite 15 over the hypotenuse, which is x. Just like we've talked about earlier, if 15 divided by x gives you sine of 25, then 15 divided by sine of 25 gives you x. We can flip-flop these. 15 divided by sine of 25. Let's type that into our calculator. 15 divided by sine of 25 gives us this, approximately 35.5. We'll write that down on our paper, but we'll make sure to keep this exact value in our calculator for our other calculations. So again, to make sure I remember that this is an approximation, I'm going to write approximately 35.5 right here. And now let's turn our attention to angle W. So in relation to angle W, 22 is the adjacent leg, and the 35.5 right here would be the opposite leg. Opposite over adjacent, that means we're using tangent. So we can say tangent of angle W, tangent of W, is equal to the opposite leg, the approximately 35.5, over the adjacent leg, which is 22. Now, what we need to do is to get W by itself, we need to get rid of tangent, which means we take the inverse tangent of this side, and we take the inverse tangent of this side. All of this cancels out so that we have the measure of angle W is equal to the inverse tangent of the answer we got earlier, the approximately 35.5, divided by 22. So let's see how to type this into our calculators. First, how do I access inverse tangent? I press second tangent, and I want to divide two numbers. So first thing, I want to go ahead and create a fraction. I can press alpha and x to get a fraction. That's one way to do it. Okay, another way to get a fraction is to press alpha and y equals. The first option that comes up is n over d. That's numerator over denominator. Now the numerator of my fraction should be the 35.5. So if I just arrow up and I select this and copy it, it will go in the top of my fraction. Okay? If not, if for some reason it doesn't, you can just type in manually as many digits as you can fit. 35.49302375, whatever you want to do. And then of course we're dividing by 22. I'm going to close my parentheses, press enter, and now we can round our answer. Our answer is approximately 58.2 degrees. So as our final answer, we can say the measure of angle W is approximately 58.2 degrees. Okay, let's wrap up by looking at two application questions. Number 17 says, a ladder leaning against a wall makes an angle of 75 degrees with the ground. If the foot of the ladder is 6 feet from the base of the wall, what is the length of the ladder? Okay, well, let's draw a right triangle. like this. And let's think about the context here. The ground makes sense to be here. The wall, up and down, and of course the ladder is leaning against the wall. Now let's label it with what the directions told us. It says that the ladder is leaning against the wall and makes an angle of 75 degrees with the ground. So the ladder and the ground meet at a 75-degree angle. They also tell us that the foot of the ladder, that would be the bottom of the ladder, is 6 feet from the base of the wall. So this distance along the ground is 6 feet. And the question they want to know is, what is the length of the ladder? Well, that means x should go right here. Well, here's our acute angle. You can see that x is our hypotenuse, and 6 feet is our adjacent side. Adjacent over hypotenuse, that would be cosine. We can say cosine of 75 equals the adjacent side, 6 over the hypotenuse, x. Just like we've said before, if 6 divided by x gives us cosine of 75, then we can flip-flop these and say 6 divided by cosine of 75 equals x. 6 divided by cosine of 75. And this is what we want to type into our calculators. When you do that, and you round to the nearest tenth, you should find that your answer is 23.2, and our units, in this case, are feet. All right, final example. It says Jaden is flying a kite and lets off 275 feet of string. If the kite is 150 feet above the ground, and assuming that the string is straight, what angle does the string make with the ground? So let's go ahead and draw a right triangle here. Here's our ground. The string is here, and this is just our height, right, measured straight up from the ground. Right, you can imagine Jaden is over here if you were drawing this. Right, you've got Jaden right here. Usually you would hold a kite in your hand, but we can imagine he's just holding it down with his foot, and then the actual end of the kite is over here. All right, now it says he lets off 275 feet of string, so the hypotenuse here should be 275 feet, and it tells us the kite is 150 feet above the ground, so 150 feet here. And they want to know what angle does the string make with the ground. So assuming he's holding the string down to the ground with his foot, that would mean this angle is right here. As we mentioned earlier, 275 is the hypotenuse, and 150 is our opposite side. So opposite over hypotenuse, that would be sine. We can say sine of x equals 150, that's the opposite side, over 275, that's the hypotenuse. Now to get x free of sine, we have to take the inverse sine of both sides of the equation. Inverse sine here, and that cancels out. So x is equal to inverse sine of 150 over 275. And you can type that into your calculator. When you do, you should find that your answer, when rounded to the nearest tenth, is 33.1. And since this is an angle measure, it's in degrees. All right, that completes our lesson. The question is, what do you need to turn in today? Well, if you followed along carefully, you should have your notes for lesson 7.5 all filled in. All you need to do is to take a picture of those notes and turn those into Canvas before 8 p.m. tonight. If you have any questions, let me know. Have a great day.